it can be used to generate new instances from the learned distribution. It had the same basic structure as Hopfield's network, but there were two types of nodes, hidden and visible ones. And the hidden nodes were there to make it possible for the network to learn more general distributions. So while theoretically interesting, in practice, the Boltzmann machine was initially of limited use. It was prohibitively demanding computationally. However, a version with fewer couplings called the restricted Boltzmann machine developed into a versatile tool, and I will soon mention it again. So far, I talked about recurrent networks with feedback connections. Many of today's deep learning methods involve feed-forward networks where information flow from an input layer to an output layer via hidden layers. In the 1980s, Hinton showed how such a network with hidden layers could be trained, and in that process, he also elucidated the important function of hidden layers. Then in the 1990s, there were applications of multi-layer networks, successful applications, for example, for the classification of handwritten digits. But the networks that one could train had relatively few couplings between consecutive layers. It remained a challenge to train more general deep structures with high connectivity between the layers. And here, and in fact, many gave up, but Hinton did not. And Hinton overcame this barrier by using this restricted Boltzmann machine. He used it to pre-train deep structures, and by this method, he succeeded in implementing examples of deep and dense structures, which was a breakthrough toward deep learning. Finally, so now I have talked about physics, how physics has been a driving force in behind innovation and development in artificial neural network. It's also interesting to see how physics as a research field is benefiting from these methods. And one example, well-established example here, is data analysis in particle physics and astrophysics. An increasingly important application is in modeling materials. For example, to search for novel, more efficient solar cells. Yet another example is in explicit physics-based climate modeling to enable higher resolution. Finally, I want also to mention two applications, successful applications outside the physics area, protein structure prediction and analysis of medical images. So thank you for your attention.
Thank you, Professor Irbeck. I think we might have John Hopfield or Jeff Hinton with us on the phone. Good morning, Professor Hinton.
Good morning.
Please accept our warmest congratulations to receiving the Nobel Prize in Physics.
Thank you very much.
How do you feel right now?
I'm flabbergasted. I had no idea this would happen. I'm very surprised.
I could imagine. I'm sitting here in this beautiful session hall of the Royal Swedish Academy of Sciences. Here at the press conference, there are many interested journalists from both the Swedish and the international press. Would you be ready to take some questions from them?
Yes.
Yes, please. Sveriges Television.
Thank you. My warmest congratulations to your achievements and to this year's Nobel Prize in Physics. My name is Susan Ritson, and my question comes from Swedish television. I know many of our viewers, also lay people, are very curious about the discoveries awarded here today. I wonder, do you remember when you realized your breakthrough awarded today, if you can bring us back in time briefly? And what were the reasons for or the inspiration for these revelations?
So I remember a couple of occasions with two of my mentors. So I have an enormous debt to David Rumelhart and Terry Sinofsky. With David Rumelhart, we rediscovered the backpropagation algorithm, and that was in the beginning of 1982. And with Terry Sinofsky, Terry and I discovered a learning algorithm for Hopfield nets that had hidden units. And I remember very well going to a meeting in Rochester where John Hopfield talked, and I first learned about the Hopfield energy function for neural networks. And after that, Terry and I worked feverishly on how to generalize neural networks to have hidden units. And at the beginning of 1982, we came up with a learning algorithm for Boltzmann machines, which are Hopfield nets with hidden units. So the most exciting times were with David Rumelhart on backpropagation and Terry Sinofsky on Boltzmann machines.
Thank you.
Okay, more questions? First here.
Hello, Bogun Radejewski from the Polish television. Congratulations. The question I have is a little bit about the future, because obviously we are very excited about what neural networks and machine learning can do now. But what we're even more excited is the prospect of what they could do in the future. What are your predictions about the degree of influence that this technology is going to have on our civilization?
I think it will have a huge influence. It will be comparable with the Industrial Revolution, but instead of exceeding people in physical strength, it's going to exceed people in intellectual ability. We have no experience of what it's like to have things smarter than us, and it's going to be wonderful in many respects. In areas like healthcare, it's going to give us much better healthcare. In almost all industries, it's going to make them more efficient. People are going to be able to do the same amount of work with an AI assistant in much less time. It'll mean huge improvements in productivity. But we also have worry about a number of possible bad consequences, particularly the threat of these things getting out of control.
I think first we have here and then there.
Hi, Simon Campanello with Dagens. Congratulations on the prize. My question is, last year you said in an interview in New York Times that you regret part of your life's work because of the risks with artificial intelligence. How do you feel about it today?
There's two kinds of regret. There's regrets where you feel guilty because you did something you knew you shouldn't have done. And then there's regret where you did something that again in the same circumstances, but it may in the end not turn out well. That second kind of regret I have. In the same circumstances, I would do the same again, but I am worried that the overall consequence of this might be systems more intelligent than us that eventually take control.
Yes, please.
Hi, congratulations on the prize. My name is Anneli Megner Arn, and I'm from TV4, a Swedish TV channel. I would like to know, you developed this Boltzmann machine, and I wonder what type of AI do you has come out of it, like GPT, or how you see breast cancer in X-rays, or how you make funny pictures in Dolly. What kind of AI do your research?
Was involved in. One was the Boltzmann machine, which was a learning algorithm for Hopfield nets with hin units. And we did eventually find a practical version of that, but that's not what's led to the main progress currently in neural nets. That's the backpropagation algorithm. And this is a way to get a neural net to learn anything. And it's the backpropagation algorithm that's led to the huge surge in AI applications and in the ability to recognize images and understand speech and to deal with natural language. It's not the Boltzmann machine that did that, it's the backpropagation algorithm.
More questions? Yeah, one here, please.
Hi, I'm from the Swedish paper Ny Teknik. Do you have any favorite AI tool that you use?
I actually use GPT-4 quite a lot. Whenever I want to know the answer to anything, I just go and ask GPT-4. I don't totally trust it because it can hallucinate, but on almost everything, it's a not very good expert, and that's very useful.
Okay. I don't see any more. Yeah. Is there one more hand there, please, in the back?
Yes, hello. Congratulations, Paul Rees from Al Jazeera English. Could you just give us a sense of where you were when you got the call, how it affected you? Is this the day you have in your diary just in case you get that call, or is it a bolt from the blue?
It was a bolt from the blue. I'm in a cheap hotel in California that doesn't have an internet connection and doesn't have a very good phone connection. I was going to get an MRI scan today, but I think I'll have to cancel that.
Okay, this seems to be the last question from the press for you, Professor Hinton. Thank you, and once again, our warmest congratulations. We look forward to see you here in Stockholm in December for the Nobel Prize ceremony.
Thank you.
Okay. So let's move on to more questions about the physics prize and the research involved, or if you want to ask the committee members questions about their work. And again, questions are welcome in either English or Swedish. Please.
Yes, if these two scientists wouldn't have existed, would we have like GPT then?
Professor Måns, do you want to address that?
That's a very difficult question to answer because it's hard to imagine. They have contributed, of course, enormously very early in the progress of this technology. So in the 80s, these these first steps were taken. And later on, other scientists have built upon these developments. So in a sense, it may have been difficult without those groundbreaking first discoveries and inventions.
Sveriges Television.
I'm thinking since John J. Hopfield is not here, I was wondering a little bit about what makes you most, what do you think is the most exciting part of his discoveries?
Professor Ibeck, do you want to address that?
When it comes to his network, he was, parts of it had been discussed earlier, but he was able to put pieces together to have a network, clear function and clear principles for how it worked in the field.
Ja.
Oh, sorry. Yes, I also wonder about the worries that Jeffrey Hinton expressed. What are your worries about this technology?
Professor Måns, you want to address?
Well, these type of worries are expressed a lot and discussed in the scientific community, and I think it is very good that they are discussed, and it contributes to the knowledge about machine learning in the society. I think it's important that as many people as possible learn about the mechanisms of machine learning so that it's not just in the hands of a few individuals. So I think, of course, Professor Hinton is one of many who express their views on this. And yeah, I think that's very good. Yeah.
Maybe I can add there that there are, of course, many discoveries and inventions over the time that has been potentially possible to misuse, but it's sort of a common responsibility for a society to have regulations to avoid that to happen. And I think that would apply too when it comes to artificial intelligence. I think that is it, actually. Time is running out. Thank you for your interest in participating in this press conference. We hope to see you again here tomorrow when we will present the Nobel Prize in Chemistry. So, thank you.
Är det okej vi går där någonstans? Jag tror ni får... Här har vi den. Varsågod. Ja. Ja, vi intervjuade honom förra året. Ja, okej.
As we come toward the end of today's ceremony, it's time to reflect on the inspiring moments we have shared and the valuable insights we have gained. Before we officially close this event, I would like to invite Dr. Sajad to share the concluding remarks. He will provide us with a few final thoughts and reflection on today's program.
Thank you. Dr. Sajad is here to explain what is being going today. Today was the session about the Nobel Prize distribution ceremony. What did you learn about this Nobel Prize distribution ceremony? Here, actually, it was decided, it was said that the machine learning, what the machine learning is, it was connected with the neural activity. Meaning to say, what